Good day, everybody. We have sort of a contrived looking problem here dealing with a arithmetic sequence, sometimes called an arithmetic progression. And y'all, there's just what they call a common difference to a line generates terms in an arithmetic progression. Just if you have a fixed constant difference between each of the terms, that's called an arithmetic sequence. Now, we're given this, again, strange looking initial condition, a3 plus a5 plus a7 is equal to 21. Now a3 would be the third term in the arithmetic progression. Now notice this would be the same thing as just saying if a sub 1 is the first term, this guy right here would be a sub 1 plus 2d, where the d is referred to as the common difference. Okay, this would be a1 plus 4d, a1 plus 2d, 4d, and 6d. Now, so what we're trying to do is minimize this product S10 times S12. And again, it's sort of a contrived problem, but some of the math and some of the arithmetic, it works out kind of nicely here. So we're trying to minimize this product of the 10th sum and the 12th sum. Okay, there's 12 terms. The sum of the first 10 terms times the sum of the first 12 terms. We want to minimize that. Okay, now this is in keeping with what I just said. We get the first term in terms of the common difference in a constant right here. So a sub 1 would be 7 minus 4d. And as you'll see, that's useful here. Here's what I just said a moment ago. S sub 10, S sub 12, they're explicit forms. Now this last part right here is based on something you can prove using triangular numbers, I guess. But one of the formulas, clean formulas for the sum of a finite arithmetic sequence is you take the number of terms in the sequence, then multiply it by the average of the first and last term. Notice that this would be the first term, just this part right here, and then this entire piece would be the last term. So I'll put L there for last, right? So we do that twice, and after we do quite a bit of algebra, I ended up with this, and you guys may want to verify this. I did double check it, but I could be wrong. So what I got was this. Now remember, this is just a quadratic expression in terms of d. All right, it's going to be a parabola that opens up. So all we have to do is find the vertex. Now notice, and I'll try to keep this on the same screen, but what you have here, if you set this equal to 0, okay, that'll give you the intercepts, and halfway between the intercepts is the vertex. Okay, so what we get right here is d is equal to negative 14? Okay, and then right here, d ends up being equal to minus 84 over 18, and I think that reduces to minus 14 over 3. Okay, now again, the vertex will happen exactly at the halfway point between these two values. So in other words, the vertex, or at least the d coordinate of the vertex, okay, has to equal to, and I'll do it like this, folks. The first coordinate would be minus 14 and then plus minus 14 over 3 all over 2. Okay, then right here we still don't know what this is going to be. You have to substitute this number back into this original expression for the product of the 10th and 12th sum. Now let's come down here and see if we have room here. Okay, so this would be equal to what's 42 minus 56. Okay, let's see, folks. This will be 42 and 14. That's minus 56 over 3 divided by 2. So I'm getting minus 28 over 3 here, folks. Minus, whoops, did I lose the marker? Okay, minus 28 over 3 is what I'm getting, folks. And y'all, when you substitute that in, I'll spare you the arithmetic on this. When you substitute minus 28 over 3 into this expression here for the product, okay, for the product, which is what we're just running with, the product of S of 10, S of 12, okay, I believe you get minus 1960. But anyway, you never know about the arithmetic. I did double check it, but I've been wrong about it before. So this is what we're looking for. It occurs at minus 20 over 3, which is the halfway point between the two x-intercepts. And so this is the answer, minus 1960. Now this is kind of an unsettling problem in the sense it's hard to verify, but what you could do if you don't believe this is the smallest one, pick any other value of d. You know, for example, just if you pick d equals 0, right? You get a number much bigger than minus 1960, right? If you pick d, any positive number, it's going to be much bigger than minus 1960. So you could check some negative numbers. I don't know. Just try some. If you do minus 10 here, you would get, for d, you would get 20. And then, I don't know, you get some number, and then, but it would always be a number greater than this minus 1960. So the answer to the question is minus 1960. That's the minimal product.